proof. We're using the characteristic of overlapping triangles and sharing information that are common to both triangles. So in triangle BEA and in triangle BDC, the piece of the triangle that they both share is this top angle B here. And so we're going to make that the focal point of this proof. The first step in any proof is to send the given information into the proof. So we're going to go ahead and insert the given information. So we have BE equal to BD and DA equal to EC. And then we're going to go ahead and focus on that part that is overlapping. And that part that is overlapping is angle B. So we're going to go ahead and say angle B is congruent to angle B, and that's the reflexive property when something is congruent to itself. We'll go ahead and insert that step. And now we have to deal with the segment statements here. We know BE is congruent to BD, and we know DA is congruent to EC. So what we want to do is we want to add BE to EC, and we want to add BD to DA. And so let's go after side BC first. So we'll say BC is equal to, and then let's go ahead and put its parts in here, BE and EC. So it's BE plus EC. And what we're doing here is we're adding segments together so that that would be the segment addition property. And then we'll go ahead and go after BA here. So BA is equal to BD plus DA. BD plus DA. And again, that's the segment addition property. Okay, so now we've got the two longer segments, and we're going to have to go after making these two segments equal to each other. So we can go ahead and say that BC is equal to, we know it's equal to this, but it's also equal to this. So we're going to say it's equal to BD plus DA. And the reason here is that we're going to substitute in, so we have a substitution property, and we're substituting in three pieces of information. We're substituting into this expression these two pieces of information plus this piece of information. So we're using lines 1 and line 2 and line 5 to make up this statement here. So let's check this a little more carefully. BC is equal to BD plus DA. And so, 1, 3, and 4. Whoops, forgot that was that line. There we go. Okay, and now that we have BA and BC equal to the same thing, we can go ahead and say BA is equal to BC. And that again is substitution, but in this case we're only using these two lines to make this statement. So we're going to pick the substitution property using two lines, and we used lines 5 and 6. Now we have enough information to prove that the triangles are congruent. We have this long segment, we have the short segments BE and BD, and we have angle B. So we have the short segment, the long segment, and the angle in between them. So I'm going to go ahead and send the proof statement to there. And like I said, we have the short side, the long side, and the angle in between. So that is side, angle, side. So the reason here is side, angle, side, congruence property. And for this statement, we have to come back and look at this line here, line 7. That's the long side, and the angle, line 3, and the short sides, BE and BD. So the short sides is line 1 there. Okay, and so that proves our statement here, and we can go ahead and have this checked.